Welcome back, students. Let us see the same chapter number 12, atoms, and this is video number 47. In this video, we will see about energy levels of n hydrogen atoms. Right? Let us see. Last time we have obtained one equation. Which was there? It is the equation of energy, that is En is equal to minus 13.6 divided by n square, and this energy is in electron volt. What is N? N is nothing but 1, 2, 3, 4 and so on. It gives number of orbit. Right? Okay. Now let us see what will happen if we will take n is equal to 1. If you will take n is equal to 1, put that n is equal to 1 in our equation, so you will get E1 is equal to minus 13.6 electron volt. Means when you are taking n is equal to 1, it means electron is orbiting nearest to the nucleus. Okay, we know that suppose this is nucleus, right? So this is first orbit, this is second orbit, this is third orbit, this is fourth orbit. So it is indicated by this: n is equal to 1, 2, n is equal to 3 and n is equal to 4. Here in this case we took n is equal to 1. It means electrons are orbiting around the nucleus in a circular path which is closest to the nucleus, and this energy is maximum having negative value. Means it having energy E1 is equal to minus 13.6 electron volt, which is the maximum, but it having a negative value, and this stage is known as ground state. Ground state of an hydrogen atom. So if you want to draw the energy level, so we can draw like this. See here, this is a graph which shows energy, and that energy is in electron volt. Here let us take minus 13.6. It means the electrons are on a ground state, so it indicates ground state of an atom. Got it? So the electrons having maximum value but negative largest. The electron having maximum value, that is minus 13.6 at n is equal to 1. This stage of energy level is known as ground state of an atom. Is it? Now, if we are taking n is equal to 2, then put the value n is equal to 2 here. So you will get E, energy of second level, is equal to minus 13.6 divided by 2. So it will be minus, how much? It will be minus 5.5.5 I am doing the It is 3.4 electron volt. Means, let us say the value here, suppose it is minus 3.4 electron volt. So at this stage you will say that here there is n is equal to 2. At a ground state n is equal to 1. So while we are placing n is equal to 2 here, the energy becomes minus 3.4 electron volt, and this stage is known as first excited state. Right? Now let us say, according to that Bohr's third hypothesis, that means when electron transit from high energy level to low energy level, it emits the radiation. Means from here, ground state to excited state. When electrons are transit, how much energy is required? Right? Let us say there is E2 high energy level minus E1, that is low energy level. Put the values of E2 and E1, so it will be minus 3.4 minus again minus 13.6, so it will be plus 10.2 electron volt. Means electron transit from ground state to first excited state. At that time energy required is 10.2 electron volt. Is it? Similarly, take the values of n is equal to 3 here, so you will get here how much energy? Minus 1.51. So while you are taking n is equal to 3 here, so it is known as second excited state of energy level. And same way, if you want to find the energy difference, that is E3 minus E1, so is equal to minus 1.51 minus 13.6, so it will be 12.09. It will be 12.09 electron volt. It means when electron transit from ground level to n is equal to 3, or you can say that when electron transit from n is equal to 1 to n is equal to 3, it requires some amount of energy. How much energy is it required? That is 12.09. Got it? So you may observe one thing. If n is equal to 1, it is 13.6. n is equal to 2, it is 3.4. n is equal to 3, it is 1.51. It means as the value of n increases, means the electrons are orbiting in outermost orbit, right? So when electron go away the nucleus, the energy decreases. Means the minimum energy required to bring out the electron from the nucleus decreases. Okay? So here minus 13.6 electron volt is known as what it called? It is ionization energy. So there is a definition of ionization energy. What is ionization energy? Minus 13.6 it is here, right? So you can say that electron is in a ground state. But if you will give plus 13.6 electron volt energy, the electron will move from ground state to out of the nucleus. Means to bring out the electron from ground state, the minimum energy required is known as ionization energy. Again, I am repeating the definition. What is ionization energy? It is the minimum energy required to bring out the electron from ground state to the nucleus. Okay, so these values are given directly. For an example, 13.6, it is very easy while you are taking n is equal to 1. But minus 3.4, how it comes? So by using equation. Same way, change the value of n is equal to 1, 2 and 3. You will get the values. Clear? There is few more analysis of this graph that we will discuss afterwards. Let us take few seconds, see the graph as well as try to understand this. Okay? Is it? Let us see. So what was the value when there was n is equal to 2? It was minus 3.40 or 3.4 electron volt. So from this graph it is clear that we have to write the few points as n increases. The energy which that minus negative energy increases, or you can say that absolute energy decreases, or you can say that ionization energy also decreases. Means if you want to remove the electron which is present in a ground state means n is equal to 1, n is very less, then ionization energy is more. You have to give plus 13.6 electron volt energy. But if you want to remove the electron present in n is equal to 3, then the ionization energy decreases. It means if the electron is orbiting around the nucleus nearest to the nucleus, then it requires high energy to remove. But from as n is increases, so if you will take n is equal to 4, means electrons are revolving in fourth orbit, and if you want to remove that electron, the energy requirement is very less. So to bring out the electron, that is known as ionization energy. So ionization energy decreases as n increases. Clear? The graph is given on page number 427. Okay, so as the value of n increases, the energy level becomes closest. Okay, and then after you will get the continuous spectral lines or energy levels. Okay, at the top you will take n is equal to infinite. When n is equal to infinite means if n is equal to infinite, at that time energy is 0 electron volt. So here energy is 0 electron volt, means the electron is already out of the nucleus, or you can say that at this stage electron is at the rest. Clear? So it is about energy levels. Okay, think of this, see this for a few seconds, then we will recall this entire graph once again. Okay, ready? Let us see once again. Okay, first of all, how to draw these energy levels? It depends upon equation. Which equation? That is E is equal to minus 13.6 upon n square, and the answer will be in electron volt. Here n is the integer number, that is 1, 2, 3, 4 and so on. If you will put n is equal to 1 here, it indicates what? It indicates ground state. Okay, so when you are putting n is equal to 1 at a ground state, the energy will be 13.6 electron volt. So it is a maximum negative value of that energy. Got it? So it is a negative value. So if you want to remove that electron from out of the nucleus, then you have to give the energy in terms of positive value. So that is known as ionization energy. What is ionization energy? That is plus 13.6, and the definition is like that: the minimum energy required to bring out the electrons from the ground state of an atom. Is it? Now, when you are putting n is equal to 2, 3, 4, these are known as excited states of an atom, right? So at this excited state, the energy decreases. See, minus 13.6, minus 3.40, minus 1.51 means as number of n increases, as electron move away the nucleus, it means the negative value of energy increases. Got it? Therefore, the ionization energy decreases. It is same manner what we have seen earlier. N is equal to 1 closest to the nucleus, n is equal to 2, 3, 4 and so on. So electrons are revolving in outermost orbit. So to remove that electron, which we required less amount of energy. So we have written previously, ionization energy decreases as n increases. Not only that, from the graph it is clear, right? As n increases, the energy level become closer to each other. And if you will take n is equal to infinite, at that time, the energy of that electron is 0 electron volt. Means that electron is already out of the nucleus. So you can say that electron at n is equal to infinite, electron is at rest. electron is at rest, take a rest. This is the end of video number 47 and topic was energy level. That is in our textbook on page number 427. You must have to go through that page number 427 of our physics textbook part 2, and then you have to